Okay, believe it or not, this is the last of the 5 types of chemical reactions. So, our learning target once again is to classify the types of chemical reactions. Our success criteria, once again, balancing a chemical equation, describe/identify a combustion reaction, and finally, predict a combustion reaction. Now, combustion reactions are pretty simple, okay? Combustion is a rapid chemical combination of a substance with oxygen involving the production of heat and light. Combustion is basically the burning. So, if we take a piece of wood and we light it, if there is oxygen, it will burn, okay? And it will give us a certain chemical reaction. Now, oxygen is not the only fuel that is used for combustion. It's the only one we're going to talk about today. But, excuse me, there are several different fuels that we can use. Some, chlorine, fluorine, nitrous oxide, nitric acid, chlorine tetrafluoride, just to name a few. Now, the only one we're going to deal with is oxygen. So when we're talking about combustion reactions, okay, we have as follows. The very first one, heptane. Okay, heptane, it is a hydrocarbon. Hept means 7. That's why we have 7 carbons there. 16 hydrogens. Now, when we have a combustion reaction, we're going to have the products being carbon dioxide and water. So, C7H16 plus oxygen yields carbon dioxide and water. Now, basically, these combustion reactions are just a practice in balancing. A practice in balancing. When I start out, I start with carbons. Okay? So I can see that I have 7 carbons on my reactant side. So I'm going to start out by putting a 7 right there. So I have my carbons balanced. Oxygen's by itself, so I'm going to save that for last. Only thing I need to know about oxygen is it's got to be an even number, because O2 can never be odd. So I look now, I've got my carbons balanced, I look at hydrogens. I have 16 on my reactant side, so if I put an 8 here, I've got 16 on my product side. Now, the only thing left is, are my oxygens even? Well, I look, here's 8. 7 and 2 is 14. So in my math, that gives me 22. Sound right? Can I make this into 22? Absolutely. 11 times 2 is 22. So when I clean that thing up and step back, I have a balanced combustion reaction. Not terribly tough. Now, the last one we're going to work here today is a little bit different because it's not just carbon and hydrogen, okay? We've got this oxygen mixed in there. Pentanol, okay? Pentanol. So C5H11OH, it's an alcohol, plus oxygen. Once again, my products are going to be the same. Carbon dioxide and water. All I need to do is balance this. Now, when I start out, I told you I always start with what? Carbon. Okay? So I see I have 5 carbon right here. I'm going to put a 5 right here. My carbons are balanced. I look at hydrogen. Here's 11 plus 1, I have 12. Makes sense that I put a 6 right here, correct? Now, the only problem is that now I have 10 and 6. I have 16 oxygens. That's great, fine and dandy, because I can get 16 right here, but I've got that 1 right there, making me have an odd number. Is that going to work? Nah, that odd number does not fit in. So, everything I've done here, I'm going to get rid of because it doesn't work. That odd number of oxygens. So, what do? Well, once again, I'm going to go back to my carbon. I'm going to put a 2 there. Will that make that oxygen even? That 1 oxygen? Yeah, it will. So now I have 10 carbons. Can I put a big number of 10 there? Yeah. Big numbers still work, just so they're balanced. I can have any number. It's a big one, but my carbons are now balanced. Hydrogens. 11, 12. 12 times 2 is 24. Put a 12 there. I have 24 hydrogens. Now let me add up my oxygens. 10 times 2 is 20. 20 and 12 is 32, right? Well, I have 2 right there. If I put 15 here, 32. 32. Clean it up. Now, I go back and check. And it's important with these. You're going to probably see it more with these combustions. I go back and check, can I reduce? That 15 makes it a little tough, right? So I cannot reduce. Therefore, I have now balanced this combustion reaction.